Hello students, welcome back. In the last two lectures, we discussed the classification of fibers based on refractive index profile and classification of fibers based on modes. Based on refractive index profile, we saw that fibers are classified as step index and gradient index fiber, where in step index fiber, the refractive index of core and clad are constant as N1 and N2 respectively. Whereas in gradient index fiber, the refractive index of core was varying, whereas for clad we kept constant. Then, based on the number of modes, we classified the fibers as single mode and multimode fibers, where single mode supports only one mode as its thickness was very small, and multimode fibers, they support large number of modes due to more thickness of the fiber. Now we can again classify the fibers by combining these two classifications. So if I combine the classification of fiber by refractive index profile and modes, I can classify as first step index multimode fiber, the first classification, whose definition is obvious, that because it is step index, so the refractive index of core and clad refractive indices are constant. We can combine these two classifications because refractive index and the thickness of the fiber are two independent parameters. So we can take these two parameters together also. Now, in step index multimode fiber, the refractive indices of core and clad are constant, and the thickness of the fiber is such that, and the thickness of the fiber is such that it supports many modes. The typical core diameter 50 to 100 micrometer. For clad CLAD, it is 150 to 250 micrometer. So here in step index fiber, how I can draw this? I'll just try to change the color so it looks nice. Now in step index fiber, we have a core. This is the central axis, and we have a clad. Okay. Now the different modes, it is multimode. So the different modes, and we discussed that different modes are characteristic of discrete angles. So different modes will be incident at different angles. So for example, one mode is going like this, then another mode, for example, is going like this. So the different modes will travel because the refractive index of core is constant. So the speed of the different modes is different because the different modes will have different optical paths inside the core. So because the path is different, so the speed of different modes will be same because the refractive index is same. So speed is same, but the optical paths they cover are different, so the time taken by different modes will be different, because time taken will be distance covered by speed. Because the distance is different by different modes, the different modes will travel with different time. So at the other end of the optical fiber, there will be a time delay, and which is, we already discussed, which is called as pulse dispersion. So with different time, causing time delay. So step index multimode fiber fibers, they have large pulse dispersion. Now we see another category, B, that is graded index multi-mode fiber. Now the definition is obvious. Graded means change. So in graded index fiber, the refractive index of core varies, whereas clad has constant refractive index. And we have already seen that the refractive index is maximum at the center of the axis and it decreases towards the core clad interface. And it supports many modes because it is multimoded fiber. So the thickness is such that it supports many mode. But now we see that in graded index fiber, what is the advantage over step index? We see that the different modes, they cover different optical paths. But here now in graded index, what is the advantage? The refractive index of the core varies. It is maximum here. You can consider the core as different layers, and these layers have different refractive index. You can think of like this. And the refractive index near the central axis, when the refractive index is more, then speed is less. As the refractive index decreases, speed increases. Also, when the ray, the mode which has a larger angle of incidence, it has more optical path, but due to less refractive index, it has more speed. So what will happen? For example, if it is meeting here, another mode which has less optical path and less speed will also have almost the same time to reach here, will take same time. So what is the advantage in graded index fiber? Different modes, they travel with different speeds and different optical paths, due to which they combine to reach at almost same time, like this. So in principle, in graded index fiber, all the modes reach at same time at the other end of the fiber, due to which there is, in principle, the pulse dispersion is greatly reduced. pulse dispersion is greatly reduced in graded index fiber. This is the advantage of graded index multimode fiber compared to the step index multimode fiber. Multimode fiber. Because the different modes travel with different speed and cover different optical path, resulting in reaching in same time at the other end. So graded index multimode fibers are advantageous compared to step index multimode fiber, where the different modes, they travel with same speed but they have different optical paths, so they will reach the other end by in different times. Mode fibers. Now in the next lecture we will try to see that we can calculate the time delay, that how much is the time delay in the two modes in step index multimode fiber. Thank you.